So I read your paper, Epigenetics Insights into Chronic Pain, where you did a study with fibromyalgia patients. I know you also did some TMS. Instead, that study, maybe you can just briefly explain what the study was about.
Yeah, there's two situations in the study. The first one, which is easier, fibromyalgia is a syndrome, and it's a disease, but it's a syndrome. It's a group of signs and symptoms that doctors put together and call this with a name. We do this for absolutely every disease. Parkinson's disease, we know what happens in the brain. We know how to treat it very well nowadays. But 60 years ago, it was just like fibromyalgia. You have some symptoms, some signs that make sense. It creates a whole, and I give it a name. And with time, we can discover that there are different flavors, different types, some treatments that work in this pathway, that pathway. So that's a general way that doctors organize what they see in patients. And it works. It's been working until now. But fibromyalgia is still in a phase where people, I wouldn't say they doubt it, because it depends on who we talk to, but there's still some discussion if it's a trait of depression, a trait of something else. At the same time, I don't see it that different from migraine, for example. Migraine is exactly the same thing. We have a type of pain, signs and symptoms that we call migraine, and there's nothing in the brain, the MRI, that tells us that the migraine is there. It's just the package. When you look at the patient, there's a trait that we call migraine. And for me, fibromyalgia is exactly the same thing. But I was always fascinated by ways to measure part of the problem and have markers. Markers is a beautiful word. It doesn't mean anything, but a marker to either try to understand better why it's happening, sometimes a marker to guide me how to treat, or even a marker that helps me to understand what the future looks like. We call it prognostic markers. Sometimes a marker doesn't help you to treat a person, but tells you, well, if this marker is there, things are not super blue sky in the future, let's do this or that. So I did two things in this study. I replicated something we had done when I was in France in 2009, well, much earlier, but we published in 2009, which is looking how the motor cortex is more or less excited in patients with fibromyalgia. That was known, we had proved before, but I wanted to replicate that because patients with fibromyalgia, it's not specific for fibromyalgia. We see this in other situations, but patients with fibromyalgia, they have something called intracortical inhibition. Which is a type of response we have in the motor cortex, in our part of the brain responsible for movement. That is how these cells inhibit. It's normal to have a degree of inhibition. In patients with fibromyalgia, they have breaks that won't work that well. The inhibition is worse than expected if you compare to healthy people. And
so get more information.
It's super hard to say information. And even though it's a motor cortex, it doesn't mean that they move differently. But it could be a difficulty to inhibit something, maybe to inhibit pain. But two things. We showed that there is a correlation between this loss of inhibition and the symptoms. Patients with more symptoms, more pain, worse sleep, more catastrophizing, they have worse inhibition, less inhibition than they should. We showed this. We also showed in another study from 2011 that when you treat patients and they improve of pain, there is a restoration of this loss of inhibition. So the bad low inhibition starts to come back to normal.
Okay.
In very strong correlation, actually, very strong, like 0.7, very strong correlation with pain improvement. It doesn't mean that one is leading to the other, but things are happening at the same time. So I found it super interesting. So one thing I wanted to assess patients, we assessed physically with questionnaires, post-mortem schema and everything. Then we did this assessment of intracortical inhibition, which was altered, I knew. But I was working very close to a psychiatrist colleague who studies genetics. And genetics in psychiatry in the last 30 years was a revolution. So I'm not a geneticist, so I'm not a specialist in epigenetics, but I started to study that because I thought it could be useful to understand fibromyalgia. So I partnered with one of the co-authors called Helen, who is a co-author, and we decided to invite patients with fibromyalgia, assess them, do the assessment of the cortical inhibition that is lower than expected, and we collected blood samples, and we did the same thing with healthy women with the same age without fibromyalgia. I say healthy because it's just because they're not healthy necessarily. They may have diabetes or something, but they don't have fibromyalgia. So people, women without and with fibromyalgia. And what we found is that, very interesting, patients with fibromyalgia had a different pattern of epigenetic trait compared to healthy people. So we looked at one of the several mechanisms called DNA methylation. So if you have the DNA, which is our molecule that we use to produce new proteins, there is a methyl, which is a submolecule that can attach to the DNA and make it more or less likely to be read by the book that I was mentioning.
Okay.
And so the first thing we found is that there was a very big difference between fibromyalgia and healthy people, which is super interesting just to start with. We don't know if it's because of fibromyalgia. We don't know if it's because they don't sleep well. We don't know if it's because they are taking medication. Medication can cause epigenetic. But these patients, they were not all sleeping bad. They were not all taking medications. And they all had a lot of changes in this package of genes that were less methylated than expected. Methylation acts like blocking the gene. So if you lose the methylation, it gets more readable by the system. And also, we found that those patients with more altered intercortical inhibition, so where the inhibition in the cortex was worse than expected, lower than expected, they had much more changes in methylation, which is interesting because I'm trying to explore something that we don't fully understand yet. But again, if you say that fibromyalgia doesn't exist, it's super interesting because I say, look, there's something in the blood, in the DNA that is different from the healthy people. Just to start the talk. I'm not saying that it's disease. I'm not saying that it causes the disease. I'm not saying that it's related to the disease directly, but it's just looking at the blood. If you give the blood to a scientist and say, analyze the methylation here and here, he can say who is healthy and who has fibromyalgia. That's interesting. And the second part is that we know that it's very, very likely, we consider that it's a fact that fibromyalgia is mainly a problem of the processing of pain in the spinal cord or in the brain. We don't have a lot of information suggesting that it's a peripheral problem. Even though pain occurs in the muscle, the muscle of people with fibromyalgia is totally normal. It's just hurt, but it's not the origin of the problem. Okay? It's the way our brain or spinal cord, we call it central processes process pain. But what's interesting is that we were analyzing peripheral blood. So there's another discussion that if we agree that what's happening with fibromyalgia occurs in the brain, that trait could also be measured in the blood. So something that could be marking outside the brain, measurable, different from healthy people, and also more altered if you have more alteration in the central processes. I think it's interesting. Of course, it's a relatively small group of patients. Of course, it's one study. Of course, epigenetics is dynamic. I don't know to which extent, if we run the study now in the same people, these changes are there or not, because we don't know yet. We're learning this. But
that would be interesting to see if you can keep measuring.
Yeah. But epigenetics can be very sensitive to change. And it can be more part of our everyday life than we thought. Because until now, we would think about big events. It could be much more dynamic and part of our everyday life than we expect. That's very interesting, I think.
I know it's a big if, but if you could isolate and keep studying how this would develop, would that mean that you could measure fibromyalgia in a blood sample?
I don't know. The answer is I don't know, because everything that we're discussing, we do not know if it causes fibromyalgia. It could be a byproduct. It could be something that happens, but we may be looking at processes that are going in the wrong direction that we don't know. So we can't right now. I would love to continue this research, but I have a provocative answer just to discuss. I know a wonderful and perfect, amazing way to assess pain in fibromyalgia.
Okay.
Asking patients.
Yes.
That's how it is. You cannot be objective in something that by definition is subjective. So it's the person who says if they have pain. I don't want anything objective to see if people have pain. I just talk to them. I want something objective if the person is in coma, if it's a fetus or a baby, or if it's someone with dementia who cannot talk. Then it's fine. Otherwise, we just talk to people. But I would love to have a marker to help me treat people effectively, or a marker of prognosis. That's just to provoke the discussion. Yeah.
I mean, I agree completely. But sometimes it's easier to believe a blood test than a person.
I know.
Unfortunately,
but again,
I wish that everyone would say the same too.
But we are not the first ones in the world. Depression. If you say that depression doesn't exist, I can say that it exists, but everybody agrees that it exists because there was an education about it and doctors learned. Because 100 years ago, people would just say you're melancholic or hysterical and depressed. Schizophrenia, migraine, no markers of the disease, nothing wrong in the hardware in the brain, and we accept and we treat and we know some mechanisms. Depression, schizophrenia. How is the MRI of someone with schizophrenia? Normal, but the brain is not working properly, very abnormally, but the hardware is the same. I think fibromyalgia is just one more disease that faces this, and we have to work on education, communication, and yeah, that's my view. Not that it's easy, but it's not the first time that human beings face a problem that is a software problem, not a hardware problem.
That's true. Just going a little bit back to epigenetics, I wanted to ask your opinion about, as I see it, epigenetics is kind of the new black in chronic research, chronic pain research. Is that also how, I mean, do you also see this trend? It's been going for a few years now, but...
Yeah. When we did the study, it was the first controlled study in chronic pain. So it's relatively new. I don't know, the paper is from 13.
Yeah.
I don't know. Yeah. So almost 10 years ago. So it's relatively recent. I'm not sure it's the new black yet. I think I don't like these things. I think we need to study if it makes sense and try to have questions and do it properly. Because sometimes when there's a lot of people making research on a topic, it gets, sometimes there's only noise and not really things that will help us. But I think that if we have money and funding to do a little, because it's not complicated, you have a blood test and it's not a high-tech thing. There's many, many places who can run epigenetic readouts of blood samples. Now, you have to remember that epigenetics is everyday part of the life of hematologists treating blood diseases and cancers for 45 years. It's part of their lives. So it's in medicine for a long, long time already. But I think that if we can learn a little bit more of chronic pain by epigenetics, it would be really good. And if we could understand diseases that are not hardware related, software diseases like fibromyalgia, problems with function, not with the problems with structure, I think we would benefit patients, I believe.
Just to kind of close up a little bit, I wanted your view in where do you see the research going? What do you hope that we know in 5 years, 10 years about fibromyalgia?
In general?
Yes.
I think research-wise, I believe we still see patients with fibromyalgia, even though there are many efforts to subgroup them, we still see them as a homogeneous group of patients. And they are clearly different. There are patterns. If you think about what I said in the beginning, syndrome, there are some flavors of fibromyalgia. I think that if we could better identify these types of fibromyalgia, some people that have pain, but pain sometimes is not even the symptom that bothers the most. There are some fibromyalgia patients who have pain, but the sleep problems are much more important, or the cognitive problems are much more important. These patients are different from patients, for example, who have pain and more mood symptoms, which are different from patients who have relatively young fibromyalgia, so short-lasting, not 20 years of symptoms. So I believe that trying to, we have a beautiful word in medicine, phenotype, which is basically characterize. If we could characterize these groups and then do research on ways to understand, not to prove that it exists, I don't think that's the way to go for research. I think we need to assume that it's there, but we need to maybe understand, okay, for this profile, I should try to use no pharmacological treatment. I should try to go through exercise. And this type of patient, this group, maybe start with a little bit of medication, improve sleep with education, and then we start to have pipelines. That would be my dream scenario. We just finished a big study that will be available soon with a non-pharmacological treatment for fibromyalgia, an international study using TMS, so a non-invasive magnetic stimulation of the brain that we use for neuropathic pain, which is a different type of pain that is more prevalent than fibromyalgia, that is effective for neuropathic pain, and we are showing that it's also for fibromyalgia. So I think, but it doesn't work for everyone. So I think strategies to look at the patient and say, look, this patient has these markers. It could be epigenetic. It could be doing the inhibition measure in the brain. Not because these things cause fibromyalgia. No, just because they are markers. They are helping me to guide me the way. Oh, with this profile, I should try first this and this and this treatment, not these, and these. If we are able to do this, because that's what we do with every disease. That's what we do with hypertension. That's what we do with diabetes. That would be really good. We could stratify patients, and based on stratify means separating groups, and then have a good idea on the priority of treatment for group A, B, and C. It would be really interesting.
I think that would make a lot of sense, because the group is so different, and people, I mean, obviously there's an overlap between symptoms, but there's also a lot of different ways to have fibromyalgia. Thank you so much, Daniel.
It's a pleasure.
This was very informative, and I think that our members and people with fibromyalgia will find this very interesting.
I hope they do.
Thank you.